So let's go to question number 19 now. A bulb is located at the bottom of a pool of liquid of refractive index N and depth H. The object emits rays upwards in all directions so that a circle of light is formed at the surface of the liquid by the rays which are refracted into the air. What happens to the rays beyond the circle? Determine the radius and area of the circle. Okay, this is similar to one question we did in class. It's a reader exercise question as well. Now, this is under a pool of liquid. Instead, I'm using a block of glass. Okay, see this? Then I'll extend that to the question given. All right, we have a pool of or a glass block like this. This is a glass block. Okay, and right under the slab, glass slab, you're keeping a bulb. You're keeping a light bulb. Then what's happening? Look at that. The ray of light is coming from here. And if it falls at critical angle, it will undergo what? Total internal reflection, right? The ray grazes the surface if it falls at what angle? Critical angle. So look at that. I can draw the critical angle now. This is critical angle. This angle of incidence is called critical angle. The angle at which the ray has fallen is critical angle. Right. Why is it critical angle? The ray has just slided over the surface. Am I correct? The ray is grazing the surface this way. Right. So inside the ray can go like this. Another ray goes like this. Another one goes like this. Likewise. Understood? But we are looking at the far right ray. Look at that. You know, this is the farthest ray and that ray just undergoes total internal reflection. Am I correct? All right. Same thing would happen on the other side. I can draw the same ray on the other side. Look at that. The ray comes in here and that also undergoes TIR like this. See this? This ray also undergoes TIR. Okay. That ray also undergoes TIR this way. Right. Now tell me, that's also undergoing TIR. And I can draw the critical angle. I can draw the normal. See this? I can draw the normal. This is the normal to the surface. And I draw the critical angle as well. This angle is called critical angle because the ray falls at critical angle so that total internal reflection just happens. Okay. Now, this is actually a two-dimensional picture. But if you take it three-dimensionally, what will you have? Look at this. This is the glass slab or glass block. Underneath, the ray of light hits at this angle and another one hits at this angle. But if you just swirl it around, you'll have rays going in all directions, right? Correct. Yes. Look at that. This is the slab and the rays are going in all directions. I can picturize it. Look at that. Look at my fingers. These are the rays going in all directions if you have a three-dimensional picture. Correct. This is like a two-dimensional picture. But if you extend that to three dimensions, you'll have rays going in all directions at this critical angle. Am I correct? So at the top of it, you will have a circle, right? It's like a cone with a circular base. All right. So look at that. I'm just drawing that circle right now. See this? This is the circle at the top. Circle at the top. Look at that. Circle at the top. So what happens is the rays of light will come out through this circle only. The rays of light will come out through the circle only. And I'm being asked to find the radius of that circle and the area of the circle. All right. Radius of the circle and area of the circle through which light is coming out. Okay. So I'll just complete the figure here. See this? I'm just completing it. Okay. This is completed. Right. Now what? This angle, if that angle is critical angle, this angle is also what? This angle is also critical angle. Why? Because these lines are parallel and this one intercepts both, right? These angles are called alternate angles. Correct? Alternate angles, isn't it? Okay. Now, opposite to this is the radius of the circle. This is radius of the circle. And this is the depth of the slab, which I call D. All right. What will be the hypotenuse then? Pythagoras helps you, right? This is what? Root of hypotenuse is equal to root of R square plus D square. Okay. Hypotenuse is equal to root of base square plus altitude square. Got it? Now, in this triangle, I'm going to find out sine C now. Tell me what is sine C? Sine C is equal to opposite side divided by hypotenuse, right? Opposite side is r divided by hypotenuse, root of r square plus d square. All right. And I also know that sine c can be written as 1 by n because I just want to relate this to the refractive index. All right. Now I got two equations for sine c and I'm going to relate them. Tell me how I relate them. 1 by n. So tell me what? 1 by n is equal to r over root of r square plus d square. All right. Okay. So I cross multiply. I'm getting what? NR is equal to, if I cross multiply, I'm getting NR is equal to, tell me what? Root of R square plus D square. I square it up, I get N square R square. I'm squaring it on the left side. On the right side, the square root gets gone. Am I correct? So that makes it what? R square. That makes it R square plus D square. All right. A little bit of simplification will do. I'll take this to left hand side. What do I get now? N square R square minus R square is equal to D square. And I take R square common. What do I have now? R square into N square minus 1 is equal to D square. What I want to find is R square. I'll keep it there. D square divided by N square minus 1. So R will be what? The square root of this. Correct. Radius of the circle is d divided by root of n square minus 1. N square minus 1. So this is the radius of the circular aperture through which light is coming out. And in case you want to find the area, look at the area, shaded area. It is circular, right? I told you already. On top, you see circular aperture, right? So what is the area of circle? Area of circle is given by pi r square. So that is equal to pi into r square is what? I've written over there, d square divided by n square minus 1. Now, this can be a standalone derivation because it's given in the reader as an exercise question, all right? Or they might ask a numerical on it. They'll give you d value, n value. D is the depth at which bulb is located. Okay, in this question, they are talking about water. So refractive index of water, you know, it is 4 by 3. All right, if it is glass, put 3 by 2 because refractance of glass is 3 by 2. But same question. So question can be to find the radius, to find the area, or they'll give you all the values. You'll have to calculate. And another question is, same question came once this way. You know, there is fish underwater or a man underwater. Look at that. This is a man underwater. How does he see the outside world? So seeing something is done how? You know, I have the perception of vision when the ray of light falls on my eye. Am I correct? I see the pen when the light from the pen falls on my eye. Am I correct? So if I want to see the outside world, light has to come from outside world. Okay. Imagine I'm underwater. I want to see the outside world, right? So light has to come in. And light has this particular property called reversibility. If light goes out through this cone, light can come in through the same cone only. Understood? Light will come in through the same cone only. So in this case, you know, I can draw the same thing. Look at that. This is the ray that's going to the horizon this way. So that's going to the horizon. Okay. Right. And on the other side also, I can draw this. Look at that. So this time I should draw the arrow this way. The ray of light is coming in, right? The ray of light is coming in. So that ray is coming from the horizon, right? This ray is also coming from the horizon, right? Okay. And all the lights can come through this cone. Am I correct? All right. So if you are asked to find the radius of the circular area through which a fish or a man underwater sees the outside world, it is the same old equation. R is equal to d divided by root of n square minus 1. Area is equal to pi d square divided by n square minus 1. Got it? So on top, you will have a circular aperture. This is the circular aperture. So you will see the outside world in a circle. Look at that, circle. Same question. The only difference is that here the light is going out through the cone. Okay. In this question, the light is coming in through the cone. All right. There is another question, sub-question in that paper. You know, what happens to the rays beyond this ray? What if a ray falls at an angle greater than this? Look at this ray. I'm drawing another ray. Look at the green ray. The green ray falls at any greater angle, right? Correct. The ray that falls beyond that, what happens? It has fallen at an angle greater than critical angle. Correct. If the ray falls at an angle greater than critical angle, it should undergo total internal reflection. Okay. So if a ray falls at an angle greater than critical angle, it should undergo total internal reflection. So it should come back like this. All right. So that is what you have to do to the second part. Do for the second part. Okay. The ray that falls beyond that ray will undergo total internal reflection. Got it? All of you got it? Write this down.